Hi everyone, today we're gonna solve a Leetcode problem called soup servings. Honestly, I think it's a pretty difficult problem. The difficulty is on its edge cases, which is how to support such a big input, 10 raised to the power of 9. But apart from that, it's a good one worth practicing. As you can see, I gave the example a thumbs down because of the large input, but just don't let it scare you. I still think you should try solving it. You may also encounter this problem in an interview in the future, although it's highly unlikely that the interviewer demands such a big input number. Alright, back to the point. We have two types of soups called soup A and soup B. Both have a volume of n millimeters. We can do 4 operations with equal probability. The first, serve 100 millimeters of soup A and 0 millimeters of soup B. Second, serve 75 millimeters of soup A and 25 millimeters of soup B. Third, serve 50 millimeters of soup A and 50 millimeters of soup B. And the fourth option, serve 25 millimeters of soup A and 75 millimeters of soup B. Notice that if the remaining volume of the soup is not enough to complete the operation, we will serve as much as possible. We stop once we no longer have some quantity of both types of soup. And answers within 10 raised to the power of minus 5 of the actual answer will be accepted. Keep that sentence in mind because it will be the key to dealing with the large inputs. We will talk about it later in the video. To solve the problem, let's first define 3 variables to help us analyze the problem. All of the 3 variables are 2-dimensional arrays. The first one, Aij, it is the probability that soup A is empty first when we start with I servings of soup A and J servings of soup B. The second variable, Abij, it is the probability that soup A and soup B are empty at the same time when we start with I servings of soup A and J servings of soup B. And the final one, answer Ij, it is the answer to the problem when we start with I servings of soup A and J servings of soup B. And the problem demands that we return the probability that soup A will be empty first, plus half the probability that A and B become empty at the same time. Notice that 2 probabilities are involved in the description. The first one, the probability that soup A will be empty first, that is actually Aij. The second one, the probability that A and B become empty at the same time, that is actually Abij. And the answer is stored in answer Ij. So according to the description, we have the following equation. Answer Ij equals Aij plus Abij multiplied by 0.5. As you can see, the key to solving the problem lies in A and AB. But how to calculate them? We can take Aij as an example. First, we draw a table here. Before going deep into the table, do you still remember what Aij means? Yes, it is the probability that soup A is empty first when we start with I servings of soup A and J servings of soup B. Okay, back to the table. As the problem demands, we have 4 options. The first one, we serve 100 millimeters of soup A and 0 millimeters of soup B. After the operation, we have I minus 100 millimeters of A and J millimeters of B. Some people may say that I may be less than 100, which makes I minus 100 negative. To simplify the problem at hand, let's not consider that probability for now. We will discuss that later. We just imagine I and J to be very big, at least greater than 100. So we only need to consider positive numbers for now. Alright, back to the point. I said that after the first operation, we have I minus 100 millimeters of A and J millimeters of B. And what's the probability of us choosing the operation? 0.25. Because we have equal probabilities to choose any of the available 4 operations. And what's the probability of sup A being empty first after choosing the operation? It is A I minus 100 J. Because the volume of sup A has decreased by 100 after this operation. The same goes for the other 3 options. I won't illustrate the other 3 rows one by one. Let's save us some time. So, do you know how to calculate Aij now? We should multiply this column and this column in each row and add them together. To be more specific, Aij equals this number multiplied by this number plus this number multiplied by this number plus this number multiplied by this number plus this number multiplied by this number, which is this equation. As you can see, 0.25 is a common multiplier, so let's extract that number out. After that, the equation becomes this. Aij equals this part multiplied by 0.25, and the first part consists of 4 numbers. This is the final equation for calculating Aij. The same goes for Abij, which is the probability that sup A and sup B are empty at the same time when we start with I servings of sup A and J servings of sup B. And the equation would be like this. It is actually similar to Aij except that we replaced A with AB. And finally, according to the equation, answer Ij equals Aij plus Abij multiplied by 0.5. Now let's replace Aij and Abij with their respective equation, and we get the equation for calculating answer Ij, which is this one. It is actually similar to Aij or Abij except that A or AB was replaced with answer in this equation. We also need to consider some edge cases. We said that we imagined I and J to be really big. It's time for us to drop that unrealistic imagination. I and J could be 0 or even negative if we use our previous equation. So all in all, 3 edge cases need to be dealt with. The first one, I is 0 or negative, J is positive. So in this case, it means that A is already empty. So Aij should be 1, Abij should be 0, and the answer Ij should be 1. The second case, I is positive, J is 0 or negative. It means that Aij is 0 because A is not empty. Abij is 0 because A and B are not empty at the same time. And in this case, answer Ij would be 0. The third case, I is negative or 0. J is negative or 0. Which means that A and B are empty at the same time, so Abij should be 1, Aij should be 0, and the answer Ij should be 0.5. We still have some issues to deal with, like how to support the big input number n, which could be 10 raised to the power of 9. But right now, let's try coding the first version and see how we can improve it. First of all, let's define a private method called subservings, which accepts 2 variables, which they are sup A volume and sup B volume. And we will invoke the new methods in the previous one. both of the parameters are in initially. And at the beginning of the method, let's deal with some edge cases. First of all, if volume of A is less than or equal to 0, and it's also the case for sub B volume. In this case, we just return the answer 0.5. Otherwise, if sub A volume is less than or equal to 0, let's return 1. Or if sub B volume is less than or equal to 0, let's return 0. Now we've come to the most important part, which is to calculate the results using the equation we said before, which is this. Let's copy and paste the equation here. We will calculate this part, this part, this part, and this part, then add the 4 parts together and multiply it by 0.25. So how to calculate the 4 parts? Actually, it's pretty easy because I is actually sub A volume in the method. J is called sub B volume in the method. And to calculate answer ij is actually to invoke subservings with I and j. So let's calculate the 4 parts. The first part, let's call it P1. It can be calculated by invoking the current method with 2 parameters. The first one, sub A volume minus 100. The second one is called sub B volume. That is the first part. The same goes for the second part, which is sub A volume minus 75 and sub B volume minus 25. Third one, sub A volume minus 50, sub B volume minus 50. The final part, P4, which is sub A volume minus 25, sub B volume minus 75. Then let's add the 4 parts together and divide it by 4. You can also multiply it by 0.25. It's the same. Now it seems that we've finished, but actually we haven't. The solution is pretty slow. The main reason is that we didn't use the cache. So the new subservings method we defined ourselves might be invoked with the same parameters multiple times, which means we need to calculate the same method with the same parameters multiple times. That is a waste of time. So to solve the problem, let's add a cache parameter here, which is a map. And let's initialize the parameter here and add the cache for the 4 parts. The key of the cache is a list of 2 numbers, which are sub A volume and sub B volume. The value of the cache is the answer corresponding to the 2 volumes. So after the edge case code, we check if the parameters are already in the cache. And if it is the case, let's just fetch the results from the cache. Otherwise, we continue the old route. And finally, after we have calculated the results, let's put that result to the cache. And return the result. Now we finally finished, right? No. If you submit the answer to Leetcode, you won't pass. The The reason lies in the big input I said before, 10 raised to the power of 9. The input could be so big that if you run the code with that number, you will get either stack overflow or runtime limit exceeded. To solve the final edge case, we need a trick. First, I can tell you that I've run the method with n equaling from 0 all the way to 10,000. And I've drawn a figure with the result data. The axis of the figure is n. The y-axis of the figure is the answer, the probability demanded by the problem. As you can see, as n becomes bigger and bigger, the answer becomes bigger too. Actually, the answer could be so big that after a certain point, the difference between the answer and 1 would be smaller than 10 raised to the power of minus 5. Still remember that magic number? Yes, look at the problem's description. Answers within 10 raised to the power of minus 5 of the actual answer will be accepted. After that point, we can just return 1 because the difference will be even smaller afterwards. So the next thing we need to do is to find out a certain input n. From that number, the difference between its answer and 1 will be so small that we can safely return 1. That can be done by writing a piece of code. First of all, we define a loop, and in it, we iterate I from 1 to 10,000. And in each iteration, we invoke the method and get its result. Then we check if the difference between 1 and the result is less than 10 raised to the power of minus 5. If it is the case, we print the input and break out of the loop. Now let's run the program. The answer is 4,451. So what should we do? We can check if the input is greater than or equal to that number at the beginning of the method. If so, we can just return 1.0. Otherwise, we continue the old route. Finally, we're done. As you can see, the solution is pretty efficient. If the video is helpful to you, please give it a thumbs up and subscribe to the channel. It will be really helpful to me. Thanks for watching. Bye.